Hi, I'm Franca, and I study electrical engineering in the University of Birmingham. This year, we had a great idea for the 2015 nPower Energy Challenge, and this is our group members. This is Vinicius, our mechanical engineering student, and Diego, our electrical and energy engineering student, and the last one, Kaio, studying civil engineering. And now, let us present to you our final project, the multi-renewable energy platform, starting with what has motivated us.
One of the main problems that we face when implementing renewable energy projects is the low ratio between the power output and the area required. In other words, renewable energy projects require a large area to generate a relatively small amount of energy, if compared to conventional energy sources. That is directly linked to economical issues. Therefore, we thought about improving somehow this power ratio area. So, what about merging different renewable energies in one single platform?
Our main inspiration was to help UK in reaching their target to reduce greenhouse gas emissions by 80% by 2050. This has led us to deeply understand the problems involving the implementation of renewable sources of energy and try to discover solutions that can overcome these difficulties.
Our first idea was based on petrol platforms, to use a structure similar to these platforms containing different types of energy generation. With this, it is possible to use the available space in a more effective way, minimizing costs and maximizing production and efficiency. In the beginning, we were going to use wind, solar, and tidal stream. A big platform would combine these three sources of energy, this way achieving our main goal, producing clean energy at a lower cost and with an effectiveness similar to other types of generation. The greatest advantage of this kind of project is that it does not rely on only one condition to produce energy. Even on windless days, our platform could rely on other sources to produce energy.
After more research, we found that solar was not the best option to be merged into our platform. This is due to UK's poor weather condition, and thus a big number of panels would be required to generate a significant amount of power. The replacement for solar had to be renewable and also greatly contribute to the final output of the platform. Our research then focused on wave power, and that is when we found the Scottish Pelamis project, which fits perfectly our purpose.
After hours of talks and meetings, we came to the final arrangement to the platform. It was decided that it would gather wind, wave and tidal stream energy. The wind model would be the new Siemens 4.0 series, providing 4 megawatts of power. To convert tidal stream energy into electricity, we would use the marine current turbine Seagen S to provide 2 megawatts of power from sea current. And finally, wave power would be gathered through the Pelamis wave energy converter, providing 750 kilowatts of power.
The execution of three separated projects in comparison to our proposal would result in a higher cost of installation and maintenance, as well as higher usage of material for both the mechanical and electrical parts. As the core of structure of the tower, the electrical facilities and the coastal infrastructure would be shared. In addition, the tasks regarding the arrangement of the three different sites, as environmental studies, for example, licenses, etc., would be toilsome and costly.
We gathered the best renewable equipment available in the market to build our multi-renewable energy platform. Here is our final project developing the 3D software SolidWorks. I will present the main dimensions of each part of the multi-renewable energy platform. Starting from the seabed, in the frontal view we can see the tidal structure with a total height of 50 meters. For safety reasons we put the working platform 10 meters above the sea level. Also, each of the rotors have a diameter of 20 meters and contains 2 blades. Going on, in the wind module has a total height of 73 meters, counting from the top of the working platform. Consisting of 3 blades, its massive rotor has a diameter of 130 meters. Both the wind and tidal modules share the structure of the tower, which has a diameter of 6 meters. Now, looking at the top view, the last module, wave power, floats in the sea so it can harvest the energy from waves, but it's attached to the platform using cables. This module has a length of 150 meters and a diameter of 3.5 meters. Finally, we have an isometric view of the whole platform showing the 3 modules together.
Regarding the economic feasibility of a project, we have made calculations and estimates about the payback time and net present value, considering different energy price scenarios as well as different interest rates. Keep in mind previous investments made by nPower on wind farms, we have stipulated a project worth £1 billion, which will consist of 50 platforms. And consider interest rate of 4%, which is lower than usual as an incentive for renewable energy projects. We found payback times ranging from 10 to 16 years, depending on the future energy prices. Also, we find positive NPV years ranging from 12 to 24.
This innovative project leans toward the future of the electricity market. Customers want companies to think about the future and to find sustainable and efficient ways of producing energy.
We think that this project suits nPower perfectly, as it goes towards the company's desire of revolutionizing the energy industry and being, at the same time, sustainable. Also, it follows nPower's trend of big projects, for example, the Green Timor, consisting of 160 turbines with a total investment greater than £2 billion. We cannot forget to mention that nPower has already taken part on projects involving the three energy sources we intend to use, even the not-so-widespread ones, tidal and wave.
nPower wants to know how to revolutionize the energy industry. Well, we're pointing the solution right here.